Um,
And so it's basically so this notation
yeah.
start from 1, stop
hmm
stop at 4, and it's sigma, so you're adding them up.
So do you use like the sequences formula?
And it'd be better to use the formula.
Okay. So is it just half times 4 and then multiplied by 5?
Uh,
I'm confused what you do with the 2r minus 1 bit.
Sorry, my pen is. To find the sum of a series of a constant. No, that's just
Yeah.
for these. It would be the. We could use the sum of a sequence formula. Uh, let's see. Uh, 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 n over 2a plus.
Plus n minus 1 d.
That's it. Was it 2a plus? What was it?
Brackets n minus 1 d. But that only works for arithmetic series. And I
Uh,
don't know.
this looks arithmetic to me.
Okay.
And so, what is
Uh,
a? What is n? What is d?
so n is 4.
Mm-hmm.
A is 1, I think. And D
Any idea about d?
is 2.
I think that'll work.
Yeah. So that's 16.
16, and I want to try this. Old calculator. That's 1, and we go up to 4.
Mm-hmm.
I get 16 as well. Fair enough. I think this formula that they gave us is for the likes of B and
Yeah,
C.
it's for B and C.
So B.
So B is half times 50. 5 times 51,
Yep. 1.
which is 1,275.
How do we do C? Very similar.
So you do like the sum till 50 minus the sum till 20.
I believe so.
Yeah.
275. Take away
Half times 20 times 19.
190.
Yeah.
And so, what do you get?
1,085.
85. Oops. 16. 1275. It was plus, not minus. That should be 21, not 19.
Hmm?
Yes.
Oh,
21.
that's 210. So the answer is 1,065.
Grand, grand, grand. Yep, looks good to me. Let us see. Yep, that's what we did. Okay, things now get weird.
Yeah.
Any idea how we do this one?
Um, so you do the sum of like 2n minus 1 minus the sum till 4, and then you solve.
Okay.
So for 2n minus 1, it would be half times 2n minus 1, and then times 2n. And then the whole thing minus half times 4 times 5, which is 10.
Mm-hmm.
So the half and the 2n cancel out. So it's just 2n squared minus n when you multiply it out. Yeah.
Yes. And so, yeah, 2n minus 1 subbed in. I think that's all right. They put a separate minus 1 plus 1, but I think we did enough.
Yeah.
You can evaluate this one. This seems the same as many others.
Which one?
The one at the bottom, example 3.
Yeah. It's 1 in 25, so you just have to you'd have to use the sum formula again, like the sequences.
I
I think you
suppose.
use the half n one for that.
Oh, okay. Go on, use the half n one.
I don't think you can.
No, I don't think you can. I think so. What would be n? What would be a? What would be d?
So n would be 25,
Mm-hmm.
a would be 4,
Mm-hmm.
and d would be 3.
Yep, I believe so. What did they do here? So they used 3 times
What?
r. So 3 times a half times 25 times 26 plus 25, because that's just 125.
Oh, okay. I
Okay.
didn't know this was a thing.
Okay. So they replace the r with sigma
with-
1 to.
Yeah.
All right. Okay. How about example 4?
So you have to do like substitute. So it would be 7 and then sum of n r equals 1.
Sorry.
Like you substitute the r.
So 7 instead of r, sigma.
Yeah. And then I think it would just be n on the top.
Uh-huh.
And then you have to write r. Minus 4. And then like sigma.
I think it would
Wait, no,
just
I
be.
think the 4 would be before the sigma, like before multiplied by.
So what would it go to up here? N?
N, but it would like say 1 instead of 4. I think the 4 is meant to be like outside. Yeah.
Okay.
I don't know if that's right, but. So I think that would give you. Well, the one that's like. So it would be 7 times half n plus 1. Minus, would that just be 4n? I don't know if that's right.
I think so.
Okay, so 7 times half n squared plus half n.
Hang on a second. So
right.
A half n, 7n plus 7 minus 4. Okay, well, we'll just expand it then.
That is not great. Okay. So, yeah, 7 over 2n plus, n squared, plus 7 over 2n minus 4n.
So that'll be 8 over 2.
Yeah.
This isn't looking good. Maybe
This is not looking right.
maybe it'll work out.
So it just says half n, 7n minus 1.
So that's going to be 7n. Yeah, that works out, I think. Minus a half n.
Oh yeah, it does. Okay.
That works out. And
And evaluate. Oh my God. Okay. So since you have the formula, you just do it till like 50 and then till 19 and like subtract them. So you can just do half n, which is 25 times 50 times 7 minus 1.
slow down. So half times 50.
7 times 50 minus 1 in brackets.
Is that what you said?
No, 7 times 50 minus 1. I think you just have to use that formula. Half n, 7 n minus 1.
Yeah.
And the whole thing minus with like half times 19. And then 7 times 19 minus 1.
Do you want to try working that out? I shall cheat.
I think it's 7471. 7,471.
Yep.
That's what I got. Yeah.
7471. Looks gorgeous to me. 7471. Boom. So yeah, 7 or 7 1. Sorry, 4 1. Yeah, exactly like what we did. Minus 19. Yep. Any questions there?
No, I get it.
Okay, so let's see exam question. Okay, exam questions. I like the looks of this. Man, they packed them in.
Mm-hmm.
Let's start with 2. It's a solving one.
Given that r equals 520. The formula. So the formula is half n times n plus 1, right?
Mm-hmm.
So you just do that is equal to 528. And then times through by 2 so that you can get rid of the half. So it's just n plus 1 is 528 times 2, which is 1056. And then expand the bracket.
Okay.
So that you have n squared plus n minus 1056 is equal to 0. And then solve this quadratic.
Mm-hmm.
To find what n is. Oh, my calculator is dead. Okay.
Tell me if there's a problem with the calculator.
No, it's just I need to replace the battery, so it keeps saying like low batteries, but it's okay. N is equal to 32.
I just want to see what happens if I do this. I don't think it'll work. Yeah, that was never going to work.
I think it's because you put everything as x.
Like, I don't have any other choice with this calculator.
Okay.
What was it?
32.
That equals 32. And I'm sure if I just put the original equation in. Yeah.
Yeah.
Okay.
Yeah, r equals
3.
Okay. So the one that's like r equals 1 and 20 on top, that would just be half times 20 times 21 times a half again for some reason. Yeah. So which is 105. So then you know half n plus 1 is equal to 105.
Mm-hmm.
So it's the same thing, you just times by 2 again, 210. So n squared plus n minus 210.
I know I shouldn't. I'm just fairly confident that the calculator will give me the positive answer.
It's 14, not 7.
I always choose lucky 7 as my guess.
Oh.
And there we go, 14, yeah.
Why do you have to put in a guess?
It uses the Newton-Raphson method, so it's like
Oh,
it needs an x0 to start the iteration.
okay. But yeah, it's 14.
Yep.
K is 14. Find it in expression 4. Oh, 4a is just like half times 2n minus 1 times 2n.
Oops. Sorry. A half.
2n minus 1. And then 2n. So that's just 2n squared minus n. If you multiply it out. Yay.
Mm-hmm.
Oh, when you start with n plus 1. Okay. I'm not really sure how to do that, but I think you just replace n with n plus 1.
Okay.
So it's like 2 a bracket n plus 1, the whole squared. Yeah, minus n plus 1. And then I'm hoping if you expand it out, it'll give you the answer.
Okay, so this is going to be
N squared plus 2n plus 1. Yeah. Minus n plus 1. I don't know how they got 3 over 2.
Let's see what happens. 2n squared plus 3n.
Again.
Is that right?
I think so. I can't really see it because it's like cut off at the bottom.
I don't know why. No, what we should get is 3 over 2 n squared minus 3 over 2 n.
How?
Something's going wrong somewhere.
But yeah.
Find an expression.
Okay, I don't know how to do it.
So for 4a, so we're saying 2n squared minus n. Let's see. A half 2n minus 1 2n. Yeah, we know that much.
Yeah.
That's 2n squared minus n, so we know that much. Okay. Part B. N plus 1. So up to that point, I think it could be...
Oh, maybe if you do like 2n squared minus n minus like half times n plus 1. Like if you just treat it like a normal question, it might work. I don't know.
Yes. Okay.
I still don't know how you get 3 over 2, but
I think it'll work.
okay.
Go on.
So 2n squared minus n minus so if you expand it, that would be n squared plus n. So half n squared plus n.
A half n squared plus a
plus
half n.
half n. So 2 minus a half. That's 3 over 2 n squared. And minus a half n.
Factorize out.
How do you factorize out 3 over 2? Like that one would work, but that's not going to work.
We're supposed to get 3 over 2n. That is because I'm a silly man. That
Yeah,
is
minus didn't. Yeah, it should
minus.
minus a half n
Yeah.
over there. So that's minus 3 over 2n, and then you can factorize out. You get minus 3 over 2n instead of 1 over 2. So it works.
Yes. There we
Yeah.
go. Okay, and 5.
Mm. So wait, you have to find like the expression for 2n first. So you have to do half times 2n times 2n plus 1. Oh, it's the same, but it's just 2n squared plus n. Yeah. And then you do 2n squared plus n minus half times n minus 1 times n. And then you expand it out and then factorize.
And
2n squared.
plus n. This is
going to give you n squared minus n over 2.
squared.
Yeah, minus half n.
And next bit.
No, there's a minus half n as well.
And so I'm just going to go and say a plus a half n.
Why is it plus a half n?
Like this.
Oh,
so
yeah, okay.
I'm just expanding the bracket in one go. So this was minus, so I'll put that as plus.
Yeah. Okay.
So
then that gives you 3 over 2n squared.
Okay.
Plus 3 over 2n. So you could factorize out. I don't know, they factorize out a half, so that would, if you factorize out a half, you'd have 3n squared plus 3n. So, and I'm guessing that factorizes to that. I don't really know.
Doesn't seem like it can.
Yeah, it would factorize to 3n, n plus 1. So I'm not entirely sure.
Did we go wrong somewhere? Let's see. 2n squared plus n. That's okay. Minus a half. N minus 1. And maybe we need to do these properly.
No, I think that was okay as well.
A half n squared minus a half n squared and then plus a half n. So that one is 2n squared plus n. So that's 3 over 2n squared. That should be 1 half. No, 3 over 2n.
Yeah, that's what we did. I don't know how it factorizes to that though.
If we were to expand this though, we'd get a quadratic like 3n squared.
Yeah, but you'd have minus 2.
We'd have plus 5n in the middle.
How?
And
How?
minus 2. So a term with no n. I'm looking it up. We made some. I don't know if we made some silly minus sign error.
Wrong. But I don't know.
Second. So this is 3 per day. Question 5. I believe.
half 2n. What? Oh,
we forgot to subtract.
oh, you have to do a weird factorizing thingy.
Let's see.
I don't get that.
So the n minus 1.
Oh, it's because it doesn't start at like 1. So you have to do 2n minus. Okay, I get it.
That's cheeky.
That's pretty confusing.
Okay. Any questions
But
about
I
that?
understand how to do it though.
Okay. That's cheeky. So it started before 1. And so it was creating problems.
Yeah.
I'll skip down to 9. Wow. This is a... It's a gold mine for exam questions, though. Okay. How about this?
Oh, you have to do. Um, oh, you have to do that like 4 times sum kr equals 1 times r. Not times r, but like r. Wouldn't you have to write r where you wrote k?
Yep.
And just k on the top. Yeah. And then the 5 would be like 1 instead of r. Yeah. So, wait, so what would that give you? Oh, would that just be 4 half times r or something? I don't know. Half
R.
times k. I'm confused.
B. K. K plus 1.
Okay. Minus 5k, I think. So that's just 2 times k squared plus k. So 2k squared plus 2k minus 5k. So yeah, 2k squared minus 3k. Find the smallest value, which it is. Okay. So would that just be 2k squared minus 3k is greater than 4,850, and then you just solve for k.
Mm-hmm.
So yeah, just make it into a quadratic and then.
And do you know how to solve quadratic inequalities?
No, I would just do it in a calculator and then like graph it.
If you have, do you have simple calculator?
I don't know. I got k is equal to 50 or minus 48.5.
Okay.
So if you graph that. Okay, my calculator isn't letting me draw the graph. I'm not really sure why.
Do you have this calculator, the one that's on the screen?
No, it keeps saying break, and I don't know why. It just says break. I don't really know.
It might just be taking too long or something. Let's see.
I put it in right, so it's probably because the battery is like dying.
2x squared minus 3x minus 4850. Let's see. Shift zoom auto. Okay. No, do you know what I should do?
So k is greater than minus 48.5 and less than 50.
Are you sure?
I think so.
Okay, let me do something. This one we just did. I'm going to graph that and separately
Graph.
4850.
That is good. Smart. And then do intersect.
Mm-hmm.
G-solve. You can do G-solve.
Yeah. Shift zoom out.
Oh,
Yeah.
it'll give you the coordinates if you do G-solve and intersect.
I think you have to actually see it though, don't you? So x is 50. That's the blue one. So when?
Yeah.
So answer.
K is less than 50.
We want where 2k squared minus 3k is
Oh,
greater
it's
than.
greater than. So K is greater than 50 and K is less than minus 48.5. So find the smallest value. What's the smallest value? For which it's greater. Would that just be minus what? I don't get that.
It's when you sub 50 in to 2k squared minus 3k, I believe.
No, it says find the smallest value of K for which the inequality is like true. So,
51.
yeah. But wouldn't the negative side be smaller? Like minus 49.5.
I think though, given the rule, won't it be adding up? Maybe I'm wrong. Like I think it's adding up, so it's increasing. Let's see. Question 9. So 51. Whoops.
Okay.
Yeah.
Okay, it has to be positive. Okay.
Yeah, because it's counting upwards, I believe.
Okay.
And
Yeah, then it's 51.
if we had, hang on, if we had a simple calculator, you can choose. There you go, inequality.
Oh, can you not do that on the graphical one?
I can't find it. I haven't never had, and you'd think that that should be minus. You'd think that they would, but
Yeah, this seems useful.
there you go.
Oh wow, that's very useful.
It's good. It's good to understand it though, the graphical, how you graph it and everything.
Yeah.
Okay, question 10.
Oh no. I have no idea how to do 10.
And sigma of that. Let's see. Sigma of that. A and B are constants.
Yeah.
So I believe it would be.
So it's like when you do the whole when you do the whole R equals 1 n r and stuff, when you solve everything, you get half n, 7n plus 1. But I don't know how you would find A and B. Oh, wait, I think I actually do know how to do it.
Go on.
Because, wait, no, the B one should just be 1 instead of R.
Yeah.
But you just do A, and then you do times half times R plus 1. And then the B one would just be, would that just be B R or something? Just B. Or BN, I think.
BN, I think, yeah.
Yeah. And then I suppose we should solve the A bit. So R squared plus R over 2 plus r. Yeah.
Should this be n instead of r?
Yeah. It should times a. So,
So that times a.
plus bn is equal to half n 7n plus 1.
I think you do it by inspection. They shouldn't have said equal. They should have said identical, I think.
Why?
So,
Why can't they say equal?
it implies that it's an equation to be solved like a equals 4, b equals 3, but it's one thing, so you're just going to do it by inspection, I believe.
Okay.
N plus bn
Is equal to 7 over 2n squared. If you solve the other side.
If you expand it, is it?
Yeah. Sorry, I meant expand. Plus a half n. So then you know that half a is equal to 7 over 2.
Mm-hmm.
So a is equal to 7. And then half a plus b is equal to half, and a is equal to 7. So 7 over 2 plus b is equal to half. And so b is equal to minus 3.
I'll take your word for it.
I don't think that's right. Hold on.
So
actually, yeah, it is.
Looks all right. B is minus 3, 7, and minus 3. 7 and minus 3. Nailed it. Nailed it. Let me just take a look at this one. Yeah, it's just AR plus B, so it's like the previous one.
Yeah,
it's
but
like
you just have to do it in reverse.
Yeah, 4 or minus 5. That was 10, 11.
Super bad.
Do you want to do 11, or you think you're okay with it?
Yeah, I don't mind.
All right, let's do it. Go on, don't wait for me.
Oh, so you have to do that like 3 and then r equals 1, 4n minus 1, r. Yeah, that thing first. 4n minus 1. And then plus, well, it's just 1, so yeah. No, it should be 1, yeah. So then you do 3 times half times r plus 1.
N?
Is it n or is it r?
It'd have to be N, I believe.
Okay.
Times N
plus n. And then just solve.
Okay.
And then you substitute n is equal to 4n minus 1.
Yes. So instead of n, 4n minus 1?
Yeah. And then that's just 4n.
So.
Yeah.
Just for the sake. Okay.
solve that after. So 3 over 2 times 16n squared minus 4n.
Uh-huh.
Plus 4n minus 1.
And that's separate, isn't it?
Is it? I don't know.
What were we multiplying? Is the plus 4 and minus 1 separate?
Yes.
I think so. Okay, what do we get here?
3 over 2 times 16.
It's 24, I believe.
Oh, okay. And then times 4. Plus 4 and minus 1. So that's just 24n squared. Minus 2n minus 1. Yay. Correct answer.
Worked out.
Calculate. You just substitute like n equals 99, I think, and then you would get the answer.
Go on, give it a go.
If my calculator decides to work. Oh. It's turning off.
Is it out of batteries?
Yeah, it says low batteries, please replace. I probably should.
I wonder what the problem could be. Oh wow. That's what I'm getting.
Okay, it's like died. I'll probably just use my phone because it's died.
And I'll check. Answer.
Backup calculator.
We were supposed to sub 25 in.
Why? Are you sure that's the right question? Yeah. Why do you have to sub 25 in? Do you get why you're meant to do n equals 25? I do not.
I think that strikes me as a crazy misprint.
That's wrong. There's no way that's right. Why would it be 25 out of nowhere?
Let me solve this.
How would solving it help?
So it's when x is a quarter and a quarter of 100 is 25.
But it's 99, it's not 100.
I know.
I don't get this.
No, it's just a misprint.
Okay.
I think the misprint isn't in the answer. It's actually in the question. That 99 should just be a 25.
Oh, okay.
I think
Who knows?
they just changed their mind. Okay, 12.
Oh, you have to do the same method, like the 4 and then sigma 2k plus 1 r equals 1, but it's just like 1.
Yeah, I see what they did. They mixed up question 11 with question 12.
Oh, okay.
That's 25 there. That's what they did. Let's see.
Does no one like check this?
Show that hence. So how?
It's the same way, like you do 4 times the whole thing, and then like write a 1.
It's the same thing, I think. Yeah.
Yeah.
All right. 12, 13, and then 14. Is 14 worth 2? Oh, yes, it is.
Oh.
Unless this one's easy for you.
I think we did a really similar one.
I don't think so.
Yeah, we did. Because it's just A And then like the sum r equals 1 n. Yeah. And
Uh,
just write like n on the top, I guess. I don't think it really matters. R plus b. And the same thing. And then just 1. So that would be a times n times half times n plus 1 plus bn. Solve. So half n squared plus a half n a. Yeah, plus bn. And then you substitute 4 for n. So that would be 8 plus 2. So 10a
H plus, okay.
plus 4b is equal to 36. And then you do 6. So that would be 18. 21a plus 3b. No, not 3b. That's wrong.
6B?
No, wait one sec. Confuse myself. Yeah, 21a plus 6b. I just confused myself. 78 simultaneous equations to solve.
Yeah. And do you know how to do them with your calculator?
Yeah, I do. There's a button.
Go on.
So I'll try. Yeah, I get it. The battery's low. Okay, it's died.
Oh, sorry. Yeah, I
No,
forgot.
it's fine.
That's all right. Okay, so A is 4, B is minus 1. A is 4, B is minus 1. I thought this would be simultaneous equations, and we didn't do a simultaneous equations one.
A similar one where it's like find A and find B. So
What number is it? Number 14. A is 4, B is minus 1. Oh, sorry, we were supposed to...
calculate something. Oh, do you just substitute 10 in the whole thing?
hold on, don't get ahead of yourself. So A is 4, so 4R, B is minus 1. That's what we're supposed to do. And then B is sub 10 in for the... Yeah, how would you do B?
For n, basically.
Okay.
So 10 times 100. 50 plus 55 times 4 minus 10.
55 times 4 minus 10, I'm sure. What is 55? That's 110. 220.
200, yeah.
210.
210. 220 minus 10 is 210.
210. Boom.
Yay.
And so those ones x a half tick.
Tick. Not that bad.
Let's see. Sums of squares and cubes. We'll take a look.
Formula.
If I was a good teacher, I'd do a plenary and we'd go back over all this stuff. I think you do it. Sums of squares and cubes. The expression is linear and the expression is quadratic. Sure. A cubic. So r squared.
Yeah.
Wow. Wow, wow, wow.
What? Wow.
Now we're playing some rock and roll. Hang on. Let them know that we're still rock and roll. Rock and roll. Okay.
So you just do like you put 40 in the formula and then you do minus like 19 for the first one. So 1/6 times 40 times 41 times 81 minus like I think the whole thing should be in like brackets, but
Bidmas.
yeah, 1/6 times 19 times 20 times 39. Mhm.
And your thing is gone?
I can use my phone.
Yeah, go on, use your phone.
Okay, so I got 22,140 minus the 19 one, which I'm doing. Minus 2,470.
Okay. What do you get?
Uh, 19,670.
Looks good. And yeah, no brackets.
Okay,
Bidmas takes care of the brackets for
I
us.
put extra brackets in for no reason,
Huh.
always.
And big.
And then the next thing you just have to use the formula. So it's 1/4 times 25 squared times 26 squared.
Cool, cool, cool. Go on, try that.
105,625.
Let me look at this one. So this is the sum of the squares of the first natural numbers. Wow. Wow. This formula for the sum of the cubes. This is...
Why is this meant to be?
This, now we're doing maths. Now we're talking natural numbers. Yeah, okay, coolios. Show that. Oh, what do they want from me now?
2n plus 1. It's just, oh, okay. I know how to do this.
I'm taking these formulae.
I'm gonna need those. I didn't find them.
I'll never remember these. I like them though. I like both of them. Okay.
So put 2n in the formula. So 1/6 times 2n times 2n plus 1 times 4n plus 1, I think,
I think so too.
minus n plus 1. And then you just put n in. So that's just copy out the formula.
Let's see. So see if we can factorize. So 1/6.
You can factorize 1/6 n and 2n plus 1. Wait, no, you can factorize 1/6 and then 2n plus 1. No, you can factorize 1/6 n out from both. And 2n plus 1, I guess. And then in big brackets, you'd have, wait, no, not these. The rest. You'd have 2 times 4n plus 1 for the first bit, which is, I guess you could expand it if you want, but minus n plus 1. 8n plus 2 minus. So that would give you 7n plus 1 for the inside. Yeah.
Is that what we were supposed to get?
Yeah.
Oh, great. It even looks the same. Okay, B.
You have to do B.
Verify that the result is true for n is
That's
1
just substituting, right?
and n is 2. But verify.
Wouldn't you just substitute it in and be like, yay, answer?
But what does that exactly verify?
I don't know.
So show that this is what when you sub in 1, do you just get 1? Do you just get 2?
No, I think you have to n is 1 and then solve.
Okay. You keep saying
So,
solve. So
yeah,
8, that's 24.
that's
4n. Is that right? Sorry,
24
4.
times 1/6. Yeah, that would be right.
What, you get 4?
4n for n is 1.
So just
Oh
4.
yeah, that's just 20. That's just 4. Sorry.
Okay, but hold on. When n is 1, you get 4. What does that mean, though? Is that because 2 squared? This is the sum of the squares of the first natural numbers.
Okay.
And so, does that
So
mean
2 to 4. Like n plus 1 would be 2.
I think it just means literally just 2 squared is 4. Okay, when n is 2, what do we get?
Uh, 12.5?
That doesn't seem good.
No, it's not.
So that's
15
15
times 5 divided by 6.
divided by
Wait, no, not divide by 6. Times 2, 6. So divide by 3. Oh, that's fine. 25.
25. And that, is that because 3 squared plus 4 squared
Yeah,
gives
I think so.
25?
Yeah. Yeah, 9 plus 16. That is going to be 25.
So I'm just trying to think of what they mean by verify.
You can look at the answer. Yeah.
Okay, so that was enough for that. Okay. When you've been asked to find the general results, it will not prove that you are correct, but if one does not, yeah, okay. Any questions there?
No.
Okay, so that's the beginning. Oh, no. Yeah, that's the beginning of those ones. I like the look of them, though, so far. Yeah, how was that for you, Amogha?
That was good.
So there's one more section of these sequences. If
I
you
actually want to do something different next week.
go on.
I don't know if you've heard, but there's this website called Integral Maths,
Yeah.
and like we use it in school a lot. And they have like these level 3, which is like really hard, and I won't do them. I can send them to you because I have an account on.
Yeah, I think I don't have a username and password for it anymore.
Yeah, so I can email to
Yeah,
you.
yeah, email them to me.
Okay.
Anything else?
No.
All right, well done, Amogha. You did great, and
Thank
I look forward to seeing you again next week.
Bye.
Have a good week. Goodbye.